All right, 5-7. Now, if you're compounding monthly or quarterly or whatever, you need to use the interest, the amount of money you have after some time is equal to the amount of money you start with. And then the formula says 1 plus the interest rate in decimal over the number of times you get the interest in a year. So compounded monthly means you're going to get it 12 times in a year, to the n times the number of years. Okay? So that's when you're compounding everything, all the compounding except for when it is continuous. This is the formula. We want to get $100 after 2 years, and it asks how much do you have to start with. So we want to end with $100. We don't know the starting amount, but we have 1 plus interest rate, that's 0.06 in decimal, over monthly, so that's 12, to the 12 times 2 years. So this is just a number, and so I will figure that number out. In the parentheses I have 1 plus 0.06 divided by 12, and then it's to the 2 times 12 is 24, and I get this number. And so I got that number, 1.127A0 equals 100, and so I will divide 100 by this, and I get $88.72. That's how much I would put into this account, and in 2 years at 6% interest compounded monthly I would end up with $100. But this is the formula. Get familiar with it. Now this one says compounded continuously, so the formula for compounded continuously is the amount you have after a while is the amount you start with, e to the interest rate in decimal times the number of years. Okay, so we want to start with 25,000, so that's A0. R is 0.07 times the number of years equals the ending amount, 80,000. So to solve for the number of years, which is in a power, we're going to have to rewrite this power equation as a log equation. But first, let's divide by the 25,000. So 80,000 divided by 25,000 is 3.2. So now to solve that, now it's down to a simple e here, and so if I do ln on both sides, since this is base e, or write this as a power equation, to what power do I take e to get 3.2, and the answer, the power I'm taking it to, is 0.07y. So I'll just divide by 0.07 on both sides. And the amount of years that it takes to make 25,000 go to 80,000 at 7% compounded continuously will be ln 3.2 divided by 0.07, the interest rate. And it turns out to be 16.6 years. Okay? So 25,000 goes to 80,000 in just 16. So $25 would go to $80 in 16.6 years. Now 25 to 80 doesn't sound like a lot, but 25,000 to 80,000 sounds a whole lot better. But that's that problem. All right.